Even the most die-hard NASA stan has to admit the Martian surface is a pretty dry subject. But what if we told you NASA's new Perseverance rover has already made startling discoveries involving a harbour seal, the Wright brothers airplane, and the merits of rigorous personal hygiene? Join us today as we prove how much this dead planet rocks and learn what has been found on Mars so far. NASA's Mars 2020 mission is all about seeking traces of the microbial life scientists think might have existed some 3 billion years ago, when conditions on Mars were probably very similar to those on Earth. If successful, technical insights gained on this mission will also help pave the way for future manned adventures to the Red Planet. At the time of writing, the rover has been on the surface for less than 100 days, but plenty has been discovered nevertheless. For one, vital proof of concept data was collected from the very landing process itself. The mission's all-new terrain relative navigation used innovative onboard mapping, cross-referencing input from the craft's onboard cameras to help pinpoint the Perseverance landing zone to within a few meters. No small feat, when even a minor overshoot would have landed the rover in trouble. Weeks of hard driving from where it needs to be. And this data will prove invaluable to future sorties. 3 types of sensors, thermocouples, heat flux sensors, and pressure transducers were deployed during entry and landing, collecting data on the temperatures and outside pressure before and after that iconic parachute was deployed. One potentially key discovery was that every last thermocouple survived the landing intact, suggesting heat shield damage was minimal. And as thermocouples are by no means mission critical, it follows that future landers could maybe get by with thinner heat shields, saving all important weight. Safely deposited on the Martian surface, Perseverance has since been doing exactly what we'd all be doing in its position, blasting rocks with its awesome space laser. You'll have seen in those photos sent back from the Red Planet that the rover's new Jezero crater home is studded with light-coloured rocks peering out from a landscape of russet-coloured soil. Well, some of those rocks have been singled out for special attention by arguably the coolest man-made device ever sent into space, the Perseverance Supercam. The Supercam rocks up to its target stone and fires a tiny pinpoint laser, accurate up to 7 meters away. When that powerful beam strikes the rock, it sends up a brief superheated cloud of plasma, comprising free-floating ions and electrons. Perseverance's onboard spectrograph reads the short plasma signature and can identify the chemical composition of the rock. 2 particular rocks scientists have identified as worthy of the Supercam treatment have been nicknamed Mars and Yigo. They're both words from the Navajo dialect, by the way, coined by Aaron Yazzie, a NASA engineer and proud Navajo Nation member. Anyway, it turns out that Mars, which means Mars, and Yigo, meaning diligent, are basalt-like in composition. So they're igneous, as in they've come from a volcano, but crucially, it seems they were molded into their present shape amid some long-gone watery environment. Proof, if it were needed, that Mars wasn't always such a dry topic. Another noteworthy rock Perseverance has pored over is nicknamed the Harbour Seal. Dark and smooth, NASA believes it was sculpted into a sinuous likeness of that playful marine carnivore by the natural erosion of powerful northwesterly winds. This finding supports existing weather modelling of the Martian atmosphere, so counts as a valid and useful data point for researchers, as well as being darn cute. Supercam's super-duper laser doesn't only furnish Perseverance with visual clues for the mineral composition of rocks. Oh no! The very sound of its zapping sci-fi laser also offers sonic clues to the makeup of stones. Indeed, one of the most groundbreaking aspects of this mission so far is that it's enabled anybody back home on Earth to listen in on the Martian landscape, thanks to Perseverance's onboard battery of microphones. In addition to the pew-pew of that laser, an audio track also dropped on NASA's SoundCloud of the rover's heavy metal wheels clanging and banging across the hard, rocking Martian terrain. Not to mention the eerie ambient susurration of the extraterrestrial winds, available to anybody who wants to hear it online. Magic, really. Even more magical, Perseverance's marvelous MOXIE unit has performed nothing short of alchemy, transforming base CO2 into life-giving oxygen. MOXIE, which stands for Mars Oxygen In Situ Resource Utilization Experiment, since you ask, is a gold-plated gizmo roughly the size of a car battery. It works by diffusing atmospheric CO2 through a non-porous disk of yttrium-stabilized zirconia, or YSZ, sandwiched between 2 porous electrodes. And on April the 20th, it produced a modest but nonetheless historic 5 grams of oxygen. That works out at around 10 minutes worth of breathable air. MOXIE isn't just the first instrument to produce oxygen on another world, paving the way for humanity to literally colonize the universe. It's also the very first device of its kind to help future missions live off the land, harnessing elements of another world's environment for fuel. This is known by fancy engineering types as in situ resource utilization. That basically means using local CO2 to make oxygen to then make rocket propellant, which is a much bigger job than plain old breathable air. In order to create enough fuel to launch, say, 4 astronauts off the Martian surface, a future mission would require approximately 15,000 pounds, or 7 metric tons, of rocket fuel and 25 metric tons of oxygen. That's obviously way too much to carry from Earth. By contrast, those 4 astronauts would only need around 1 metric ton between them for breathing, and MOXIE has proved that can certainly be done by a larger descendant unit anyway. A breathtaking, historic first. Of course, the most eye-catching wheeze on this mission so far has been the successful deployment of NASA's $80 million Ingenuity helicopter. Affectionately named Ginny, if you think that's cute, wait till you learn Perseverance is nicknamed Percy, this diminutive chopper only last month cemented its place in the annals of science by performing the first powered flight on another world. And the very fact it survived the trip at all is a miracle. If Ingenuity would have crashed after the very first flight, we would still have met a couple of huge milestones, one NASA technician told fans on Reddit. Surviving launch, charging while en route, surviving the entry, descent, and landing, also deploying from the rover and surviving the cold Martian night, these are no small tasks. Certainly, making an airworthy vehicle that's dinky enough to be stowed on an interplanetary rover is an amazing achievement and paves the way for future missions exploring areas unsuitable for rovers. As we speak, engineers are greedily collecting data from this one-of-a-kind thin air copter to be used in the design of smart micro-drones, or drones that fly at high altitude for applications here on Earth. One particularly arresting scientific observation concerned the solar panels mounted near Ginny's rotor blades. Engineers spent a long time figuring if there was some way of mitigating the inevitable coating of Mars dust the panels would attract, and lose power in doing so. Various solutions, like mini windscreen wipers, were pitched and rejected on the basis they'd add too much complexity and weight. But when those dual rotors started spinning, technicians noticed Ginny's solar output actually increased by a couple of percentage points. Engineers have speculated this is because airflow from the blades self-cleaned Ginny's dusty solar panels. Hygiene matters, even on Mars. Ginny is also carrying a very special payload, a postage stamp-sized square of fabric that was once part of the Wright brothers' historic 1903 flying plane was carefully attached to the craft, a tribute to the real aviation OGs. It's still up there now. Before we get carried away with how adorable that is, Mimi Aung, NASA's Ingenuity program manager, had this to say. "We've been thinking so long about having our Wright brothers moment," she said modestly. "We will take a moment to celebrate our success and then take a cue from Orville and Wilbur regarding what to do next." So what did the Wright brothers do next? History shows they got back to work.
Good morning. I thought before we'd start today, because the first assignment is coming up on Tuesday, if anyone had any questions about those, I could talk about them or address them before we start lecture. So if anyone has any, they're free to speak up or type in chat, and I'll address them before we talk about ambiguity. That can be instructions about the assignment or any specific question that you've had troubles with so far.
So for number 2, understanding presuppositions,
Yeah.
either A or B can be presupposed, right? Not just B.
It's either A that's presupposed or B. So just one of them is going to be a presupposition.
Okay.
Yeah.
I have a question about question 1.
Okay.
So we'll have to consider the relationships from A to B and then B to A. So from what I've been doing, it would yield different results if you were to do it the other way around.
Yeah, usually. So there might be one case here where you get the same thing from A to B and B to A. So for example, if you have a synonymous sentence, usually that means that you have entailment in both directions. But for the most part, you'll get different results from A to B and B to A. In a lot of cases, you'll have one inference from A to B or from B to A, and then you might have nothing in the other direction. And that's completely normal. That's something that can happen in quite a few cases as well. So if you get nothing from B to A, that's also completely fine.
So we need to consider both directions for all the questions.
Yeah, from 1 through 4.
Do we have to show any like failed tests? So if like, for example, a question isn't presupposition, do we have to show the tests not working?
You do not have to show them not working if you do not want to. Um, Otherwise, there would be a lot of work shown. It's up to you. But I just need to see the tests that are successful. Yeah, so if you do have any more questions at any time, of course, you can email me or post in the discussion board. It's the first assignment. Also, one person's emailed me about vaccinations and stuff, and I know things like that are happening. So, because this is the 20 to 25 range right now, if you are getting vaccinated soon, and if you have any sicknesses related to that that affect your assignment submissions, or if it's around the first test date and you get sick, let me know and I can give you a couple days extension on anything happening. So, you don't have to worry about that sort of sickness affecting your submissions. I mean, it's happening in BC right now. So if that does come up, just let me know. No worries, no formal documents or anything. I'll just give you 48, 72 hours and you can submit things later. Um, just just let me know and I'll take care of it. So let's finish ambiguity. So some of this might be review, but there's definitely a new type of ambiguity that you haven't seen before in other courses, and we'll talk about that briefly. So Um, ambiguity is when you have one word or a small structure, we can call it a phrase, that has more than one meaning associated with it. Usually, when it's a single word that has multiple categories, we call it lexical ambiguity. Well, a category difference or completely different meanings. So, for example, 22 and 23, this is your typical case of lexical ambiguity. So, I can't believe that Roger Clemens' award winning bat beat every other competitor. If you know who Roger Clemens is, he used to be very popular in baseball. So, when you think of Roger Clemens and bat, you might think of a baseball bat. And here's my lovely drawing of a baseball bat. It's probably not as thin as it should be at the bottom. But you might think of course, the Halloween flying things. It's got fangs and ears. There you go. So it's lexically ambiguous. It can mean one of the two things. And if you are aware of the context, you can determine which one it probably is. That's what context helps us with. It helps us determine or disambiguate the meaning of a particular word. But if you don't know the context and you're just given the word in isolation, usually what happens is you pick the one that's most frequent in the lexicon. So if bat typically means the flying thing, like say 80% of the time, you would assume that bat means the flying thing when you hear it. Here is the most traditional example you see in almost every textbook is the word bank. If you bring a bottle to the bank, you can retrieve liquid assets. Okay, so here's bank. This could mean like the place where you store money. This is, of course, the most typical meaning of bank. Well, it's where you could store money if you were born in the 1970s and own that kind of stuff. Let's face it, we'll never own money in our lives. Or it's the land at either edge of a river, the place where you swim. So if you were born in a city and you've never been to one of the smaller towns, you might have never heard this definition of bank before. You might only be familiar with the money kind. Um, but of course, if you're born somewhere in the countryside, or I shouldn't say countryside, but born near lakes in smaller towns, the definition of riverbank might be more known to you. So, which one you disambiguate to could depend on how you grew up. But this is just lexical ambiguity, and typically this is just one word. So I mean, this is usually when in casual conversation when you say, "Oh, what you just said was ambiguous." This is usually what we mean. Usually, you say a single word when you make your jokes, your puns. It's usually a case of lexical ambiguity. The second one is structural ambiguity. And what I want to say with structural ambiguity is that we're not focused on tree structures here. That's not what this course is at this point in time. The tree structures I have here are just for illustration. So if you look at this and you think, it's been a while, I don't know how to do this, don't worry, this is just for illustrative purposes. But structural ambiguity happens when you have the same word categories. So this is important. The same word categories, but the structure assigned to those word categories is different and they give you different interpretations. So, for example, in this sentence, young workers and managers are needed for this company. If we take a look at the word categories for this, young is an adjective, workers and managers are both nouns, and is a conjunction. So and takes two nouns and it combines them together. In both interpretations, these categories are exactly the same. It's how we put the adjective and the nouns together that change the meaning. So we have structural ambiguity. So on the left side, what we do first, and I'll illustrate this on the sentence as well, so that way we don't just need the tree structure to see this. What we can do is we can combine workers and managers together first. So that's what we've done here. We've said workers and managers is a compound, and then we're taking young and we're modifying the entire compound. So we're saying that workers and managers are both young. So young workers and managers are needed for this company. This is one interpretation of that. Young workers and managers are needed for this company. And that's what this tree structure is representing. So another way of looking at this is you have this adjective phrase that is directly modifying this noun phrase to the right. So these are called sisters in a tree. And when you have sisters in a tree, this means that they are directly modifying each other, in this case, with an adjective and a noun. In another case, on the right side, we have a second interpretation. So if I get rid of my little brackets in the sentence, instead what we're doing for the second interpretation is we're saying that young is only describing the workers. So the adjective young is describing the workers, and then managers is not being described by young. So we get young workers, that's one noun phrase. Managers is a second noun phrase. And then those two independent noun phrases are being joined together by and. So we get this compound young workers and managers. So the managers could be young, they could be old, they could be whatever, but there's no modifying description for managers. So in this case, when we take a look at what young is modifying, young is only a sister to workers. So young is only restricting the definition of workers in this case. So this is structural ambiguity because the word categories are all the same for both of these interpretations, but the way that the adjective is modifying either the entire compound noun phrase or just a single noun is what's different here, giving us two different interpretations. Another example that I have on the Canvas lecture page, which is probably one that you saw in LING 220, which I'll pan over to because it's a really nice example. Where is my Chrome? Is the example, I shot an elephant in my pajamas. So here I use determiners, but prepositional phrase ambiguity or prepositional phrase attachment ambiguity is another example of structural ambiguity. So when you say, I shot an elephant in my pajamas, is it an elephant in my pajamas that you shot? So is it the case where you're shooting the entire noun phrase? Or is it the case that you're shooting an elephant? So you're just shooting an elephant, that noun phrase, and the fact that you're in your pajamas is like this extra bit of information in how you're shooting it. So is this prepositional phrase being attached to the elephant, or is the prepositional phrase being attached to the verb that's describing how you're doing the shooting? And you could illustrate this in a tree structure, or really you could just illustrate this with brackets and different colors to say, what are you shooting? Are you shooting the noun phrase, an elephant in my pajamas, or are you just shooting an elephant? And this is how the action is being done, also in red with the shooting. Like, there's two ways that you could illustrate how this interpretation goes, either with a complex tree or just with simple brackets. I mean, it's your choice in the end how you want to illustrate these things. So pick your poison. But in this course, what matters is just, tell me the meanings if you're asked to describe structural ambiguity. I just need to know what the meanings and interpretations are. I don't need the structures. But that's the key difference between lexical ambiguity and structural ambiguity. If it's lexical ambiguity, this means that there's usually either two meanings for one word, or there's a word category change. In structural ambiguity, the categories are always the same. It's just two different structures. So are we good with lexical and structural ambiguity differences? Yes. Okay. That was probably review for quite a few of you, but still good to go over this stuff. Okay. The last one, which we talked about a little bit last week, is scope ambiguity, but I want to delve into it a little bit more. So scope ambiguity is that sentence, everybody loves someone. And I use the terms everyone and someone, and these are what are called indefinite pronouns or quantified pronouns. Depends who you talk to. If you take LING 200, they're called indefinites. If you look at syntax, they're called quantified pronouns. And these happen when you have things called quantifiers. Usually different quantifiers. So if you have like some and every, or many and few, so different quantifiers, two or more in a sentence. But they can also happen when you have numerals, and they can even be the same numerals. So two different noun phrases, let's say, two fish saw two cats. You could get two different meanings from that sentence. So we had this case, every comedian is making some person laugh. This is very similar to everyone loves someone. So to sort of review this, every comedian is making some person laugh. There is one case where we can say every comedian is making some particular person laugh. So there's some particular person out there, and here's all these different comedians. Let's say there's just 4 out there, just to keep the drawing simple. And each of these 4 comedians is making this one particular person laugh. Okay, so this is one interpretation. There's some particular person, and every comedian is making that person laugh. And we have a notation for this. We say that some scopes over every. So we have this greater than sign. Oh, that's not the right direction. That's the right direction. Greater than sign. And how we read this is we say scopes over. And I just like to think of this casually as being like the focus. So the focus is some person. That's the initial focus. There's some particular person, and every other person makes that person laugh. And then there's the other interpretation, where we would say that every scopes over some. So the focus is on every comedian first. So we could say, okay, there's a bunch of comedians, and then for each comedian out there, they're making some person or other laugh. So maybe 2 comedians are making the same person laugh. It doesn't matter who they're making laugh, but all the different comedians are making at least one person or other laugh. So two different interpretations, and this happens because there are two different quantifiers inside a noun phrase. So it's because we have every comedian, some person, and they're separated within the sentence. So this happens with numerals too, like every person ate one bean. It's the exact same idea. So I could draw the picture again, but I'll use a different color to point these out. They match the same interpretations as what we've just done. So in the case of every person ate one bean, we could say there's one particular bean that every person shared. So this is the case where one scopes over every. So we could say here there's one bean that every person shared. That would be a really weird interpretation, but it exists. It's just something that we'd never think of because beans are very small. So we wouldn't think of that. If we said every person ate one pizza, then yeah, that would be an interpretation that we might think of. But every person ate one bean, it's probably not that interpretation. Usually, if we said every person ate one bean, we would think of this second interpretation where every scopes over one, and we'd have all these different people, we'd have all these different beans, and we'd say that every person out there ate one bean. So, how do we feel about scope ambiguity? Do the different interpretations make sense to people? Couple thumbs up, few thumbs up, several thumbs up. I don't know the word after several, but that's good to see. Okay, so I do have some practice questions that I have filled out that I'll post on Canvas just because I don't have any practice or assignment questions on them, and I do want to move on to set theory today. So I'll have those out for you. What I will say though is that we are going to revisit scope ambiguity later in the course. And when we revisit scope ambiguity, we're going to have some formalisms introduced already, and we're going to talk about movement. So um, you talk about movement a lot in Link 322, and we're not going to need movement in Link 322 or the movement in Link 220 if you've done it in order to do the movement in this course. So we're going to kind of start fresh. And the thing with scope ambiguity that I'll reiterate from the first week is that with lexical ambiguity, ambiguity arises because a word has two categories or two meanings. So we can say that there's differences in the word. Structural ambiguity has two interpretations because there's differences in the structure. But with scope ambiguity, the words have one fixed meaning. The structure, there's one fixed structure. So the fact that there's two interpretations is weird because there should be either a difference in word meaning or there should be a difference in structure. Because when you have a sentence and you're building up truth from the words to the phrases to the sentence level to figure out when something's true or not, uh, it's a systematic process. So when you get to the top of the tree and you say, this is a sentence and this is what it means, if there's only one way to get up to the top of the tree, there should only be one interpretation. So there actually is a second structure to these sentences, but we need to do some movement and some fancy stuff behind the scenes to get there. So later in the course, we'll revisit these sentences and figure out how we can actually get two different structures out of these sentences using some behind the scenes movement. So some movement that happens after we pronounce a sentence, which is a little bit different from the movement in syntax. In syntax, we move words around so that way we can pronounce them. In semantics, we move words around after we pronounce them in order so that way we can understand what a sentence means. So it's kind of a preview of the fancy behind the scenes math that goes on in the world of meaning. So here is where the course gets into the quantitative cue part. This is where people start to get a little scared. So let me introduce why we're about to do what we're doing in the course and why there's even math and semantics at all. Okay. So what we're trying to do at this point and what we're doing going forward is we're trying to figure out when a sentence is true or false. We're trying to figure out the meanings of sentences. And we're trying to do it in a way that is objective and logical, and a way that computers could understand as well. We're trying to do it in a way that is more than just language. So we're trying to find a formal system that we can use to analyze, say, nouns and verbs and adjectives and adverbs and prepositions and sentences. So our first goal in this course is to figure out how can we represent things like nouns. What is a noun? How can we represent that formally? What about verbs? What about prepositions? What about adjectives? What about a proper name? So how does a proper name differ from a noun? Like, for instance, uh, when I say Jim or Fido compared to human and dog, how do these things differ? Because there is a difference between these two. When I say Jim, I could have a human. When I say Fido, I could have a dog or two circles and four lines. It's the same thing. Um, but when I say something like human, really a human is a big collection of things. It's a big collection of people. When I say dog, it's really a big collection of different things that are dogs. So these are different objects. What about a verb? Something like likes. I mean, how do you even represent a verb? Because when you think about a verb's usage, there's a lot of stuff that goes on in a verb. I mean, it's transitive, for example. If you don't know what transitive means, it just means that there's sort of this framework. You have to say X likes Y. There has to be a liker and there has to be a likee. So someone has to like someone else or something. You can't just say Trevor likes. That's ungrammatical. I have to like something. So it's almost like a relationship between two things. So if we want to represent likes, really it's a bunch of pairs of things. So how do we represent this formally? These are tough questions in a sense. We can try to do this with words, but then how does a computer understand it? So our first goal in the course is to establish these things mathematically as objects. And we're going to do this a little bit abstractly, but I'll try to make sure that with every abstract thing that we do, we tie it back to some language example or some real world example. So that way we can actually think about it in terms of like the alphabet or IPA symbols. We won't do too much phonetics, don't worry. Or word categories or adjectives or nouns or something that we can work with linguistically. And we'll do as much practice as we can do as we go on. So that way, we can really make sure that we understand the basics before you get thrown into the deep end. Okay. So this is about word categories. And then the next set of lectures will be about the sentence level. And then once we finish those, we can jump into actually doing tree structures and putting everything together. So we have a setup, two major setup lectures, and then we put everything together with what's called the truth conditional meaning of sentences lecture. So this will take about 3 to 4 weeks, which is a long time, I know, for setup, but it is necessary setup. Otherwise, things get very intense and very confusing. Okay, so let's start very basic. And we're going to start with this notion of an object. So an object is literally anything you can imagine. So we can start with an object that is something in English that we know, for instance, like a vowel. So if we take a vowel, and I'm just going to use letters here, I'm not going to use IPA, but if we take something like the letter A, this is an object. The letter E, I, O, and U, these are all different objects. And if we want to group these together and call these the vowels, we can group these objects into what is called a set. So we put A, E, I, O, U together, and this is called a set. And we can name our sets. So I could call this the set of English vowels. And this is a nice visual representation of a set. So usually what we do is we don't draw these in circles, but instead we use more of a formal notation with curly braces. So what I would do instead is I would write some curly braces, and I would write all of my objects out, A, E, I, O, U. And I would put little commas in between each of my objects there. So A, E, I, O, and U, these are all different objects in my set, and I would give them a name like English vowels. And usually, just to make this a little bit simpler to write out, we just give it one letter as a name. So I'd call this V. I could call it E, I could call it F, I could call it A, I could call it English vowels. The name doesn't matter. We usually just use capital letters as a nice convenient method to make it faster to write.
Trevor, I have a question.
Yep.
Is this kind of like when you're doing computer programming, it's like declaring an integer almost?
It's kind of like a more like a dictionary or a list.
Or a dictionary, yeah. Okay.
Yeah. The difference between this is that the sets, the order doesn't matter in this case.
Okay.
So, although I've done A, E, I, O, U, I could also do E, I, O, U, A, and it's the same thing. So I like to use a circle here as a representation because a circle doesn't have an order. So I wrote A, E, I, O, U in the circle, but I could do O, E, I, A, U. It doesn't matter.
Okay, thanks.
Yeah. So formally, everything inside of a set is what's called an element. So I called these objects, but if we have something inside of a set, that's called an element. Okay. Most of the sets that we use in semantics are called finite sets, which means they have like a certain number of things in them, but we can have an infinite number as well. So I do have a somewhat mathy example here with the numbers from 1 to infinity. So the natural numbers here. So 1, 2, 3, 4. And usually what we do is we use these ... dots. And when we see these ... dots, this just means that there is an implied pattern. So when we don't want to keep writing, we just use the ... dots to shorten things up. So when you see the ... dots or the ellipses at the end of a set, this usually means it continues on forever. So forever, this is an infinite set. So it never ends. But let me just move this up a little bit. If I wanted to talk about, say, the English consonants, for example, and I don't want to write 26 things out, I might use the ellipses here to make writing that a little bit shorter. So I might write A, B, C. I'll put some ellipses here for ... and then I'll write X, Y, Z at the end. And this ... just means there's an implied pattern that I'm continuing with the alphabet, and then I'm ending with X, Y, Z. And I'm just calling it C for English consonants. I write C so that way in your head, you see the C and you're like, oh, that's probably the consonants. It just helps you trigger your memory a little bit better. So these are sets and these are elements. So in linguistics, we use things that are relevant to linguistics. So normally these are the names of people, or these are IPA symbols, or these are word categories, or these are letters. But you can really use anything that you want. You could use abstract objects, you could use mathematical notation. You could use things that are not even connected to each other.
When you're using the implied pattern, then the order of the elements matter, right?
For the implied pattern, yeah, it helps to write it in a way where the pattern makes sense to people. So it does matter for your writing, but in general, the order in a set does not matter. So yeah, it helps for understanding, yes.
Okay, thank you.
But in general, the order in a set does not matter. Okay, so here's some more notation for sets. So again, we got some mathematical notation. And again, what I'll say with all this notation stuff is don't let the notation like boggle your mind down. Worry about the concept first and understanding the concept, and then worry about the notation after. The notation will come to you once you understand the concept. And we can always work through the notation together in office hours or in an appointment. So if we have an element that's in a set, so I have an example here. I say M has sugar, milk, eggs, flour, and baking soda. And I want to verify and say, okay, sugar is in my set M. Then I have this symbol. This is an epsilon. So normally in the IPA, you see epsilon written as E like that. This symbol here, this is another variation of epsilon. And this is read is an element. So this just means that sugar on the left is a member of that set M. So it's in that set. So this is read as sugar is an element of M because sugar is in that set M, as we can see from that example. And then on the right here, we can say that tomato is not an element of our set M. So in this case, we just use the epsilon, that's the element symbol, and we put a line through it. So tomato is not in that set. So this set M could be, I don't know, the ingredients for making a cake, for example, or whatever sort of pastry uses sugar, milk, eggs, flour, and baking soda. Another example that we could do is we could say that milk is an element of M because milk is in that set. And we could say that Carlos is not an element of M because Carlos is not in that set. And again, I mean, there's like a billion things that are not in that set M. So you could really pick like anything that's not one of those 5 things, and it's not going to be an M. There's only 5 things in that set M. So that's just some notation. And formally, see the formal definition up here. So we say if an object little a is an element of the set big A, we write that little a is an element of big A. So even though I'm explaining things with examples, it's always a good idea to go back and try to read the formal definition on your own, just to make sure that you can read the notation and understand it. I know it's always a pain sometimes to look back at it, but just training yourself to read these formal notation is good. It gives you some skills reading linguistic papers as well, because when you read syntax papers and semantics papers, or morphology papers or phonology papers too, sometimes you see definitions like this, and it can be a little bit tough at first. So getting some practice later is always a good idea. Okay, so that's the element symbol. We do use this sometime, and you will get some practice with it. Here is one more definitional thing. We don't use it too much, but it's just a good thing to know. If we have a set with just one member in it, so for instance, if I wanted a set that was the set containing the first letter of the alphabet, which has just the letter A in it, which I could also just write as the set containing A, then this is what's called a singleton. So a singleton is a set with one thing in it. So the other example I have here is I say that B is the set of main characters in the Titanic played by Leonardo DiCaprio. So it's a very specific set, and that set contains the character Jack. So the set has one thing in it, Jack. So this is what's called a singleton. You can also just be really fancy and call it the set with one element. That's also another thing that people say, which is fine. People understand it, a singleton or the set with one element. Okay, a few conventions for sets. We talked about the first one, but just to re-illustrate it, the order in a set does not matter. So whether it's A, B, C, D, E, or whether it's E, D, B, C, A, or B, E, D, A, C, it's the same set. So to illustrate this with a smaller one, if I have the set containing AB, and I have the set containing BA, they're literally the same thing. And if I draw this visually, it would just be a circle with two things in it, AB. I mean, how could I draw BA differently? I could put B and A in different positions, but when you have a circle containing two things, I mean, there's really no difference in where they are, right? I mean, it's a circle. There's no order within a circle. So they're the same set. Furthermore, within a set, we don't care how many times an object is in it. A set is just about whether something is in it or not. So it's like if you're making a grocery list. I mean, a grocery list isn't always the best example because sometimes you want 6 of something, but it's more so like, what do I need from the store? Do I need eggs or not? I don't care how many eggs I need, just do I need eggs or not? Do I need milk or not? So when we have a set with the same element more than once, we don't include it again. We just remove it. So for instance, if I have A, B, C, A, B, I already have, so I have A, B, well, I see A again, so I can remove it. I see B again, I can remove it. Okay, C is new, so it can stay. I see A again, I can remove it. I see B again, I can remove it. So I'm left with the set ABC. But even if I don't remove those symbols again, they're really the same thing. So AB, ABC, AB is the same thing as ABC because we don't include members twice. We just care whether the element is in there or not. And I will give you a question at some point about this point. So just be prepared for that one. And finally, this one may seem dumb to you. As a human, this may seem dumb to you. But as a computer, this will make more sense if you think like a computer, because computers are not smart. Elements and objects are very particular. So if you have a word and you change it from lowercase to uppercase, or if you add a symbol afterwards, a computer does not understand that you might want those two things to be the same. It will treat those objects as separate objects. So my example here is with the words can and can in quotation marks, or can and can in quotation marks. It will treat those things as two different objects, two different elements. The second example I have here is one in quotation marks, and one with the prime symbol or the apostrophe afterwards. It will treat those as 3 different elements because they look different. So if we were to draw this out as a set, we would have one in quotation marks, and we would have one prime or one apostrophe, and should really draw it the other way. But these are 3 different things. So although as a human, we want to consider these to be the same thing, a computer does not think like that. A computer treats these as 3 different elements, and there is a practice exercise on Canvas that will test exactly that and allow you to practice that. That's on the lecture page on Canvas, not on the practice exercise that will be released sometime next week. Okay, one more thing before some practice exercise. It is possible to have a set with nothing in it. So we can draw this visually. That's the set with nothing in it. It's just a circle. And we use a special symbol for this. We just draw the little circle with the line through it. So this is called the empty set or the null set. I like the term empty set because it describes exactly what it means. And you can write this with the normal notation with curly braces, with there being nothing in it, if that's what makes it easier for you, or you can use the empty set symbol. I prefer the empty set symbol, but whatever you choose works for me. And this sometimes can be confusing because it is possible to have something like this. So you can have a set with the empty set inside of it. And this leads us into the last point, is that a set can have another set as an element. And my advice to you when you see this is just to think of another set as being an object. So for example, I have B containing the set, or sorry, B is the set containing the object A, the object B, and the object which is a set containing CD. So let me draw this. It's best for me to draw this. So there's A, there's B, and there's the set CD. So when I ask myself what's inside this set, there's three things inside this set. A is an element of B, B is an element of B here. So this is my set B. And then I have this set containing CD, that's an element of B. And we do not dig in further. So we do not break apart these elements. So we don't dig into this set further. So for instance, we say that C is not an element of B. So we can't go into this set further. And D is not an element of B. So we don't break C and D apart. We just take a look at that object. And that's it. It's sort of like when you open up an Amazon package and you see there's like another box inside. You know, you just say, okay, inside this Amazon package, there's that box. You don't break it up further. You know, what's inside your Amazon package is that box. You can open that box further afterwards and say, well, what's inside this smaller box? But just in terms of your big Amazon package, we would just go one layer deep. It's sort of like asking ourselves, if we have a prepositional phrase, what are its daughters? The daughters of a prepositional phrase are the preposition and the noun phrase. We don't dig deeper in this case. If you want to dig deeper and say, what's the daughter of the noun phrase, then you would dig deeper then. But for now, if we say, what's the daughter of the prepositional phrase, we just go one layer deep. Okay. Because there's only 5 minutes left, I think what I'll do is we'll start with the practice question on Monday, or sorry, on Tuesday, just as a review to set us up. And instead, if there's any questions about today, I'll take those, and otherwise we'll just end a few minutes early. So are there any questions about the sets and elements that we've covered today? When is assignment 1 due again? Assignment 1 is due Tuesday by 10:30 a.m. So that's the 25th, right before class. And if you do have any sickness from vaccinations or anything else, just let me know and I can give you an extension. Oh, I'll talk about how the solutions are being given out. So there won't be a PDF with solutions, but I will put out a video where I talk about them, and I will also be marking them. So I'll be marking them myself I will be marking everything in this course. So the TA will not be marking, I will be marking. I will give you feedback, written feedback, and I will be uploading your work back to you and on Canvas. So you will get the PDF with all the comments and your grades. And that should be usually within 2 days or so of submission. So by Thursday, you should have your feedback. So before the Friday class. And the solution video will be out. It won't be out on the Tuesday. It will be out when I release the assignments, just in case people do submit things a little bit later because of extensions. Something about corrections on assignments or marks, or was that about the quizzes? The corrections are for the practice exercises. So if you do not pass the practice exercises after 5 attempts, then you can make an appointment with me or the TA, and we can basically make sure that you correct any mistakes or misunderstandings so that way you can pass them. The practice exercises are meant to make sure you don't fall behind and that you're able to do the assignments and clear up any basic misunderstandings. So the assignments are more so like, can you do the work on your own or in a group and actually answer the major questions of the course? And the practice exercises are to make sure in an online environment you can get off the ground and you can do the basics. So those are meant to make sure that you can do things on your own, and we're there to assist you and make sure that you can pass. So the idea is that nobody fails the course, and the practice exercises are to make sure that you cannot fail this course.
So to my understanding, the practice exercises come in chunks. So are you going to mark them in chunks and give opportunities for five attempts for the chunks?
The practice exercises are available as we go through the lectures, so you can already do the first one and they're automatically graded. So as soon as you do them, you'll get a score immediately. They're all multiple choice. I think, yeah, quite a few people have done them already. The first one at least. So I recommend, like, before you do the first assignment is to do the inferences and semantic relations practice exercise a few times. And if you struggle with them, email me or post on the discussion point post on the discussion board, or book an office hour appointment on me on Monday or something so you can talk with me and we can go over those. Just to make sure that when you do the assignment, you have a better understanding of what you did wrong on the practice exercise so you can do the assignment better. You get a full point for 75% or greater. There's no partial marks on the practice exercise. It's either pass and full point or fail and no point. Well, it's not fail and no point. It's not pass and talk to me until you get the full point. The only way you're not getting a full point on the practice exercise is if you don't pass and you don't talk to me at all. That practice exercise bin is supposed to be 100% at the end of the course for everybody. That's the goal. But yeah, that's it for today. If there's any other questions, I'll stick around. I do have private office hour appointment with someone right now. So if you do have questions, stick around and chat. I'll put you in the waiting room and I'll get to you after that. But yeah, I'll see you all next week. Bug me over email or the discussion board. I am getting my vaccine today, so I might be a little sick this weekend. So if I do take a while to respond to you, I'm sorry, but I'll get to you when I can. Enjoy your weekend, everyone.
Thank you.
Bye.